Guys, diodes are very interesting electronic components which are available in wide variety of choices. For example, I have bunch of them over here for you all to see. So this, for example, is a through hole type rectifier diode. Diodes are also available as packages. For example, these bridge rectifiers that you see over here, this is a combination of 4 diodes in one package for ease of use. This is a nice heavy duty metal body one. You can get them in plastic. This is 10 amp. There's one more variety over here that looks like this. Then there's one more package that I particularly like. This is the TO220 package. This thing is very easy to mount on your circuits, and plus you can put a heat sink on them to get rid of the heat. It looks like a transistor or a MOSFET, but believe me, this is a diode. If you carefully see over here, you can see this is 2 diodes in one package. So that is TO220 for you. Plus there are some specialized applications. So next time you change the channel in your TV or turn on your air conditioner, you need to thank these little guys. These things are known as photodiodes. You will find them commonly inside TV or air conditioners for receiving the signals of remote. Then we have these laser diodes. This one is from a DVD. There are these little boys over here. These things are commonly used for security alarms. They're also used for laser pointers. Very small laser diodes, but they have quite a strong beam. And finally, these are the favorite of the lot, shiny, nice little light emitting diodes or LEDs. Something like this which we use in our homes to light up our bedroom or study table or whatever. But today in this particular video, we are going to talk about two kinds of diodes which look very similar. For example, these are known as through hole general purpose silicon rectifier diode, and there's a bit of underdog over here. It looks very similar, but the properties of this thing is very different. This thing is known as a Schottky diode. So in this particular video, we are going to talk about how to test them, what are the differences, what are the benefits of having a Schottky diode. So you guys quickly go down below and hit those like and subscribe buttons for me, and let's launch this particular video. Let us talk about the physical properties of a diode first. A diode looks something like this, and as we know that the diode works like a one-way valve. So what it will do is it will allow the electrical energy or the electrical current to flow in a particular direction, but it is going to block any kind of a reverse flow of the current. And for that, this diode has 2 terminals. As you can see, the one over here has got a silver strip. This thing is known as a cathode. So it doesn't matter if it's a general purpose silicon diode or if it is a Schottky diode, it's going to physically look like this. Generally the through hole components that I'm talking about, they look like this. So the one with the silver strip is the cathode, and this thing, the other terminal, is known as the anode. Now there is another difference between these diodes, that is the symbol. I'll put up the symbols on your screen, you can check them. And now let's come to some important differences in their properties, specifically their electrical properties. And to explain their electrical properties, what I'm going to do is I'm going to turn on this trusty little clamp meter. By the way guys, if you need a good clamp meter, then affiliate buying link for this thing is available in the description below. This is my Mastec multimeter, brought in 2006. I don't know, it's like 17 years now, and it has been working fine. So yeah, always invest in good quality stuff. And let's start by measuring the electrical properties of these diodes. And to measure any kind of diode, what we do is, remember the silver strip that we talked about? We put the negative probe of the multimeter over there, and the positive probe, we put it like this. And let's focus on the display of our multimeter. So what is this reading? This reading is known as the dropout voltage. Now 0.458 is the amount of voltage that this diode will drop. Or in better sense, you can say that this is the amount of voltage that this diode will waste. Basically, it's going to convert it to heat when the diode is working. Alright, so that is 0.457 for a general purpose silicon rectifier diode. Let's test this one as well. This is a 3 amp version. Alright, again, it's roughly the same. You can say it's going to waste half a volt. Alright, let's come to this underdog. The method for measuring is the same. The terminal configuration is the same, so let's measure it like this. And guys, focus on the screen. All right, so this is 0.188. Let's round it up to 0.2 volts. So why is this thing important? All right, so I'm going to explain how to convert these values into wasted energy or wasted heat. Okay, say for example, if we have a project where we are using this cheap little general purpose silicon rectifier diode which is dropping half a volt. All right, and let's assume that we have 1 ampere flowing through this diode, or you can say 1 ampere flowing through your circuit, which includes this diode. And if we multiply these values, if we multiply 1 amp by the value on the multimeter, that is half a volt, all right, we get the resultant energy loss in watts. That is, it's going to waste half a watt of energy as heat. And assuming that we need our devices to be as efficient as possible, as light as possible, you don't want bulky heat sinks on them, this kind of wasteful property of general purpose silicon diode is not very helpful. So what we do is, when speaking about our computer power supplies, our mobile phones, our LED drivers, basically any kind of electronic component which has a high efficiency power supply, what we do is we simply go for these Schottky diodes. As you can see, the voltage dropout is 0.187. Even if we round it up to 0.2 volts multiplied by 1 ampere, all right, the same equation that we used over here, if 1 ampere current is flowing through this, the amount of wasted energy in watts is going to be 0.2. That is less than half the amount of energy that this boy was wasting. All right, so that is the reason we generally prefer using Schottky diodes in SMPS type power supplies. By the way, the Schottky diodes that we are testing here today are SR560. I'll provide datasheet and buying links for you in the description below or in the first comment. You can go ahead and check them out. To support my channel, make sure to purchase things using my affiliate links which have been provided over there. There are some other advantages to having a Schottky diode. So the first advantage that we talked about is that it has much lower wattage loss or power loss compared to silicon rectifier diode. The other advantage is that it supports high switching frequency. For example, I have a bunch of circuits over here. These are known as DC to DC buck converters. And what these buck converters do is that the chips in these buck converters allow switching up to 180 kilohertz. All right, that is very fast switching. So what this 180 kilohertz switching means is that the diode is being turned on or off. All right, it's being forward biased, reverse biased. I mean, the polarity is changing hundreds of thousands of times each second. It's just going on off, something like that, or the polarity of the electrical energy is changing. And if we use this kind of regular silicon rectifier diode, it's not going to work. It will simply fail or it will start leaking current. So in that scenario, a Schottky diode allows for much faster response time. It allows for very quick switching. So if we have a high frequency switching power supply like these buck or boost converters, or the SMPS power supplies in your computer, they'll use Schottky diode so that it allows for faster switching frequency. So these things can work very fast. Their activation time and their response time is much better than general purpose silicon rectifier diode. Now at this point you might be thinking that, well, if Schottky diodes have so many advantages, why not just use them everywhere? I mean, why even these things exist? These things should not exist, right? No, you're wrong. So these general purpose silicon rectifier diodes also have some advantages. For example, one thing being cost. These things are much cheaper. You will get them for around say 5 rupees or 10 rupees per piece. On the other hand, Schottky diode, this thing will cost 45, 50, 60 rupees per piece. Other thing is that the amount of voltage that a regular silicon rectifier diode supports is much higher. So these things are generally rated for easily, like for example, this one is 6A4 6 amp diode. All right, it will easily support 400 volts. It's available in different varieties. You can buy them in 400, 600, 1000 volt as well. All right, so these things can take much higher amount of voltage, much higher amount of reverse voltage. They can withstand it. A Schottky diode on the other hand is generally rated at like 40, 45 volts, 60 volts, something like that. So you cannot use them for mains AC to DC conversion applications. Say if you want a little circuit that converts 220 volt AC into DC, these things will not survive. So Schottky diodes do not work in high voltage environment. for high voltage environment, you will have to rely on these regular general purpose silicon diodes, and their power loss at such high voltage, you know, even if it drops half a volt, it doesn't really matter, because the input voltage is 240 volts, and if it drops half a volt from that, so you get 240 volts minus half a volt. It's not a lot, all right? But for low voltage DC applications, say if you have a power supply which provides 5 volt, all right, and if you use this diode, it's going to subtract half a volt, so the resultant output is only 4.5. That is what you don't want. So we use these things, all right, so they have low dropout, and it's going to subtract only 0.2 or 0.3 volts, and hence it is better suited for low voltage DC applications. I believe that both of these kinds of diodes are very useful in their respective applications. If you want to learn more about diodes or in electronics in general, then there will be a bunch of cards popping up on your screen like this. You can click on them and watch those respective videos. Take care and have a nice day, guys.